In this video, we are going to review some important vocabulary and concepts about polynomials. Please have your note sheet beside you and fill it in as we go along with the video. Feel free to stop it at any time. Here we have an example of a polynomial that is of degree 5. So the degree of a polynomial is the highest exponent of all the terms. So in case of my example here, the highest exponent is a 5. So this would be a degree 5 polynomial. If your polynomial is in standard form, then it's quite easy to find that highest exponent. You will also see polynomials written with the exponent of n, x to the n power, and then the next term would be x to the n minus 1. So you're going down by 1 each time. So this is just kind of a general form that you'll see. Now, something interesting about degrees of polynomials, it tells us something about the graph and something about the shape of it. If the exponent is an even number, so we call that an even degree, so something like the exponent of 2, 4, 6, 8, and so forth, then we know that both ends of the graph will be going in the same direction. I'm going to show you an example of that in just a minute. Actually, I'll give you one right now. So let's say it's of degree 2. That's our parabola. And notice that the ends are going in the same direction. They can either be both going up or both going down. If it is an odd degree, so that highest exponent is a 1, 2, 3, a 1, 3, 5, or 7, or so forth, an odd, then both ends will be going in the opposite direction. So something like that. So be sure to record this information about even degrees and odd degrees in your table. Our next vocabulary words are leading term and leading coefficient. Keep in mind that for polynomials, we must first put the polynomial in standard form, meaning the highest exponent needs to be listed first. So this would be our leading term, which you're going to find out has some very significance to the graph, and the leading coefficient. Polynomials have real zeros. So recall that zeros are x-intercepts. And so for this example, this is a polynomial. It has 3 x-intercepts, or 3 zeros, one at -3, one at 0, and another at +3. Now we have the term relative or local. Your textbook uses the word local, but relative is just as familiar or used. So relative or local minimums and maximums. So looking at the graph, this would be where the function changes from increasing to decreasing. So that would be a relative maximum. Or it changes from decreasing to increasing. In this case, this would be a relative minimum. Over here we have another relative maximum, and here is a relative minimum. So in order for you to call it a minimum or maximum, it does have to change from either increasing to decreasing or decreasing to increasing. We also have what we call an absolute or global minimum and maximum. To be an absolute maximum, okay, it must be the absolute highest point in the entire graph. So in this case, we have this point right here. That is the absolutely highest point in the entire graph. So that would be our absolute maximum. Now at this bottom point here, this is just a relative minimum because it's not the absolute lowest point. The lowest points on the graph are actually way down here, and they continue going down. So this is just a relative minimum. It's not an absolute or global minimum. Going on to the back sheet of your notes, you'll hear this term relative extrema. All that is referring to are the relative minimum and maximums. They use this word extrema just to shorten so that you don't have to say minimum and maximums all the time. So it's just referring to the minimums and maximums. End behavior. Recall that the end behavior is what's happening at the ends of the function. As x gets more positive, as x becomes a really large positive number, what is happening to the function? Or as x gets more negative, as x becomes a large negative number, what is happening to our function? In the last video that you watched about end behavior, you learned something about polynomials and how this first term, x to the fifth power, that actually determines or affects the end behavior. Before we go on to the next term, let's go back up here. You can add this to your notes. As x goes to positive infinity, f of x goes to, and we'll just use this example here, it is also going to positive infinity. And then when we look at when x goes to negative infinity, f of x in this example is going to negative infinity. So anytime you give end behavior, you are always doing x to positive infinity, x goes to negative infinity. And then the graph determines what's happening for the f of x. We're going to expand on our definition of odd and even functions. Let's begin with an odd function. Here is a graph of an odd function. If you recall, if you take one part of the graph and you rotate it 180 degrees, I'm going to show it like this, 180 degrees, you get the other half. And that rotation does have to be about the origin. If we have an odd function then, we also know that it's also an odd degree, meaning that the highest exponent, so let me write like this, would be like x to the fifth power. Now it also might have an x to the second plus an x. However, the highest degree is an odd degree. So that's what we mean by that. And we also know that the ends point in opposite directions, as in this graph. For an even function, okay, we know it has to be symmetrical about the y-axis. So here is my y-axis. If we fold it along that line, we would see that one half of the graph is symmetrical with the other. If it's an even function, it also has an even degree as the highest exponent. So in this case, it might be x to the fourth plus x to the third plus x to the second. Now it has other exponents, but the highest one is an even number. So that makes it an even degree. We also then know that the ends point in the same direction. Now just because something has an odd degree, it doesn't mean it's an odd function. And just because it's an even degree does not mean it's an even function. Both of these, the odd function has to have this 180 degree rotation about the origin. An even function must be symmetrical. All right, now we have increasing and decreasing intervals. The important thing to remember when you look at increasing and decreasing intervals on a graph is that you read the graph from left to right. So it's not like end behavior. Here you have to read the graph from left to right. So we're going to look at this interval from negative infinity to negative 2. And I'm going to highlight that. That means we're going from, and these are the, I should probably put these are the x's. Okay. So we're going from x is negative infinity to negative 2. So that would be this area right here. If you read that from left to right, we are going down. So we are decreasing. Okay, now let's go from negative 2, right here. We're going to go from x equals negative 2 to 0. And I'm going to highlight that. That goes from here up to 0. So again, reading it from left to right, we're going in that direction. So that would be an increasing interval. All right, now let's go from x equals 0 to x equals 2. That's this area. So let me highlight that. And if we read it from left to right, we notice that the function is going down or it's decreasing. So this interval would be a decreasing interval. And then finally, from x equals 2 to infinity, that's from here to positive infinity. Again, I'm going to highlight it. So we're talking about that area right there, which, reading left to right, we see that it is increasing. This is our last term for this video, and that is positive or negative values, or positive and negative function values. Sometimes they won't use the word function, but that's what's implied. When you're looking for positive or negative function values, the function value means the y value. So where on this graph are the y values positive? I want to highlight them. That would be from here to here, from here to here, and from there. So all of those would have a y value that's positive. But what if we wanted to look at areas that were negative? I'm going to change colors. Well, these would give you a y value that's negative. This would all be y values that are negative, and so would these. So let's go ahead and label those. And I'm going to say green equals negative values. And here, the yellow equals positive values. And on your notes, you may choose to use some colored pencils or even some highlighters or markers.